Okay, so for number 7, we need to figure out how many distinct points of intersection exist for two particular curves. So our polar curves are r equals 1 and r squared equals cosine 2 theta. So we have two curves here and we want to see where they intersect. Well, as you can imagine, one way would be to set the equations equal to each other and solve. That's certainly one way to do it. Possibly a quicker way is if you knew what these graphs looked like. I'm sure you guys know what r equals 1 looks like. So that's all points that have a distance 1 from the origin. Well, that's a circle with radius 1. Okay, but now what does this one look like? So this is a particular form that it would be worth memorizing for this exam. So when you have r squared equals and you have either a cosine or a sine with a double angle, that's a very specific type of graph. It's always a two-leaved rows. It probably has another more specific name than that. But the difference between the cosine and the sine version of that is in which orientation the roses are. So just like in your typical four-leaved rows and things like that, the cosine version has leaves along the axes. The sine one has leaves that are tangent to the axes. So we need to just think about which way is this going to be pointing. Well, let's see what happens when we choose 0 for theta. So what's happening this way? Cosine of 0 is 1, and r squared equals 1 has solution 1. So we get a point right there. That does intersect r equals 1, so there's 1 point. So we know that these leaves must be along the axes, but we need to know which. Well, let's just try the other points on the axes. At pi over 2, 2 times pi over 2 would be pi, and cosine of pi is negative 1. R squared equals negative 1 does not exist in the real numbers, so we don't have anything going on up here. So that one must be missing. So if you think of your normal cosine 2 theta graph that has 4 leaves, this one only has 2, and this top and bottom one are going to be missing. So it's going to end up looking like this, kind of like an infinity symbol. And you can see here that we have 2 intersection points at each end. So how would we do that algebraically? Well, if r equals 1, then we would know r squared equals 1 if we just squared both sides. So we could set 1 equal to cosine 2 theta and solve that. Now remember, that is obviously going to have infinitely many solutions, but it said distinct, so if we keep going around this circle, we're going to hit these 2 points plenty of times, but that's not what we mean. So we can restrict this to a 0 to 2 pi type of thing going on here. So where is cosine 2 theta equals 1? Well, when theta is 0 or theta is pi, because cosine of 0 is 1, cosine of 2 pi is 1. And as you might have expected, or it definitely correlates with the graph, because whereas theta equals 0? Theta equals 0 is straight this way, here's that point. Whereas theta equals pi, straight this way, here's that point. So either by doing it from the graph or manipulating the equations, we get that there's 2 points of intersection for this graph. It's possible, though, that with questions like this, you could get ones that the algebra would not give you every point of intersection. So knowing what the graphs look like is very important. For example, if we were still intersecting with this graph, r squared equals cosine 2 theta, but we wanted to circle something like this. I'm not going to work this one out here, but if you were to, the algebraic approach would only give you these 2 points of intersection and not the one at the origin. So knowing what the graphs look like is also going to be pretty handy, at least for matching, for confirming answers, as well as getting answers that might not have otherwise been